In this video, we are interested to understand an idea in macroeconomics known as GDP deflator. So, what is GDP deflator? Intuitively, GDP deflator is the aggregate measure of prices. It is an index number, it is just a number which represents the overall prices in the economy. Why overall? Because we are using this term called GDP, and GDP is about market value of all final goods and services that we produced in a country. So we are talking of everything that we are producing. And so GDP deflator is computed as the ratio of nominal over real multiplied by 100. And this 100 you are multiplying just to make sure that the base year GDP deflator is an index number. You start with number 100 instead of 1. And it's nothing but the ratio of nominal and real. Now, nominal GDP, if you would know, or if you would see from my other video, is defined as GDP measured at current prices. And so, nominal GDP gets influenced or gets affected by only by quantity and prices, because you're measuring GDP at current prices, and prices change every year, and what you produce also changes every year. And hence, a nominal GDP will change based on the quantity force and the price force. But real GDP is only about quantities, because you are keeping prices constant. Real GDP is defined as GDP at constant prices, so you're not allowing prices to change, and hence any changes in GDP in real GDP will only be reflective of the quantity force. And so in some sense, when you take a ratio of the two, what you get is just the price force. I mean, it's not Q multiplied by P divided by Q, which gives you P again, but it's more of the force which is driving each of these things. So nominal GDP is driven by price and quantity force, but real GDP is driven by only the quantity force, because real GDP's prices are constant. And hence, when you take the ratio of the two, you only get what is known as the price force, which we call it a GDP deflator. The other way one can look at it is what is real GDP? Real GDP is nominal GDP. Again, nominal GDP is a combination of quantity force and price force. Think about a balloon which is having two pipes attached, and both are pumping air. One is quantity and other is price. But when you take away, now you're dividing the price force from it. So when you deflate the nominal GDP by price force, then what you get is just the quantity effect. And that's what real GDP is about. Right? So you can think about in this way as well, that from nominal GDP, you would want to deflate, hence the word deflator, some by some factor, by some amount, and that will give you the real effect of production or real GDP. So you can look at in either ways, both are derived from each other. So it's just algebraic manipulation. And inflation rate is a percentage change in GDP deflator, right? So GDP deflator itself is not inflation rate. GDP deflator is a measure of inflation. So GDP deflator, let me write that, is something that measures inflation or measure of prices. And a change in this measure of price level is what we get as nominal inflation rate. So here's some kind of worked out numbers. Say you have 3 years of data, nominal GDP of each of the years and real GDP of each of the years. Then a deflator, this number, let's take out this number, is nothing but 7,500, which is the nominal GDP of that year, multiplied by 7,000, divided by 7,000 times 100. That gives you 107.14. The deflator for year 3 is the nominal GDP of year 3, which is 10,000, and the real GDP of year 3 is 9,000. And then you are again going to multiply by 100. Again, you are multiplying by 100 just so that the index number starts with 100. So that will give you 111.11. And again, if you go for this, this is 6,000 divided by 6,000 times 100. right? So now we start with 100. In year one, or your base year, your nominal GDP and real GDP will be the same numbers, because the current year is the year in which you are using the base year's prices. And so in year one, instead of starting with 100, you want the index number to start with instead of 1. If you take 6,000 divided by 6,000, you get 1. But instead of starting with 1, you start with 100, and then you go forward after 100. And a change in this between 100, so this is give you 100, this gives you 107.14, and this gives you 111.11. And how much is the change between these two, right? It's 107. I know it's straightforward over here, but I'll still do the work. Divided by 100, right? It's the old level, it's the new level minus the old divided by the old value, and then times 100, so you get a percentage sign, so that gives you 7.14%, right? You can just take the difference here because the base is 100. But here, how much is the change from 107 to 111? Well, the change is 111.11 minus 107.14. That's how much is the change, but it's the change is relative to not 100 now, but 107.14, right? So the percentage change, to get the percentage symbol, we have to multiply by 100, and that will give you 3.70%. So this is the inflation rate in the year 2 and year 3. In the first year, because it's a base year, you don't have any previous year to compare with, you cannot compute that.